Hello, my wonderful grade 2 and grade 3s. I'm so happy you are joining me today on this wonderful Wednesday for some math. So grab your math book, turn on that math brain, and let's get started. Okay, so I was drawing my array. So I have one group of 6. Now 1, 2, 3, 4, 5, 6. That's two groups of 6. 1, 2, 3, 4, 5, 6. That's three groups of 6. Now build my house. I have multiplication, so it's 3 groups of 6. 3 times 6. Now remember, if you're not familiar with 3 times 6, you could always count by threes. 3, 6, 9, 12, 15, 18. 3 times 6 is 18. Now I have all 3 numbers in my fact family. So do you. If you want to pause the video and make your fact family, then come back and check. Let's practice that. So pause it, make your fact family, and come back and check it. All right, so I hope you did that. 6 times 3 is 18, commutative property. 18 divided by 3 is 6. 18 divided by 6 is 3. Now, the bottom of my fact family house is always repeated addition. So I go 6 plus 6 plus 6 equals 18. And then I have 1, 2, 3, 4, 5, 6 groups of 3 is also 18. And there you go. I've got these 2 here. That's my fact family for 3 times 6. Now 3 times 3, this is a nice square. Watch. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I have 3 groups of 3. Now I'm going to do, and look, it's a square. It's a pretty sad square on my part, but that's okay. Now, because it's 3 and 3 both ways, it's a square number, it's square. So now I am going to write out my fact family. I forgot what I was saying for a minute. All right, 3 times 3 is 9. Now for this one, I can't write another fact. You could write 3 times 3 out again, but it doesn't matter which way you write the 3's, they're gonna look the same. So I could take this 3 and put it here, and put this 3 over here, and 3 times 3 is 9. You don't have to do that. And then 9 divided by 3 is 3. Again, I don't have to write that twice because it's the same fact. So this family doesn't have as many variations. Now, 3 plus 3 plus 3 equals 9. That's the only repeated addition I can do for this. Okay. Now, I'm going to move on to the next here. When we multiply numbers, we can use skip counting to help us remember our facts. Let's review skip counting by 5s. See if you can find any patterns in the 100 chart once you're done. So all you're going to do, and I really would love it if you could pause the video and try this on your own. If you really don't want to do that, you could work along with me to begin with and then pause the video and try it on your own. But I'm going to go quick because we've done this before. This is a review. So you're just going to start at 5s and shade in every 5th number. Okay, so look, let's do it real quick. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100! Whew. Now, you guys all know how to count by 5s. I've heard everyone do it. I know you've got this. So now we're going to write the skip counting sequence. Now, it's going to be a little bit hard to see, but you have all the numbers up here. So I'll do my best to show you, but you guys have got this, okay? So we'll I'll count as we go. You can go along with me, or you can do this part on your own. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. 100. Whew, you did it. Now it says, did you know that you can use skip counting to solve a multiplication equation? This is the strategy I usually teach for 5 times 5 because it's such an easy strategy to remember because you learn to skip count by 5s very early on in your school career. Okay? So, example, 3 times 5, think, and you can't really see my hands, but 5, 10, 15. I skip counted by 5 3 times, and I know it's 15. Remember, even if the equation is flipped, you can still skip count by 5s. For example, 5 times 4, think 5, 10, 15, 20. Write the skip counting sequence that you could use to solve 5 times 5. 5, 10, 15, 20, 25. Now, 4 times 5. 5, 10, 15, 20. Now, I'm going to switch to my camera view and I'm going to give you a couple ideas of ways that you can practice this and use this to get better at multiplication, okay? And I just wanted to add that a polygon has to have at least 3 straight edges. I just wanted to give you a definition. A polygon has to have at least 3 straight lines and angles. So this one, these little things, remember we just talked about where the lines meet, that's the angle. This one has 1, 2, 3 straight lines and 3 angles. This one has 4 straight lines and 4 angles. This one has 6 straight lines and 6 angles, and this one is our parallelogram, and it has 4 straight lines and 4 angles. The circle, unfortunately, has none of those things. It is a circle with no straight lines and no angles. All right, let's work on some addition practice, guys. So some of these you're gonna need to regroup and some of these you aren't. Okay, I'm gonna zoom in and hopefully I can show it to you right on the paper rather than having to use the board. Okay, let's see. Oh, I can totally do this. Okay, so 222 plus 139. So I am going to be modeling partial sums today. Now, I know some of you really like Grandma and Grandpa's way, and that's awesome. Keep working on it. Grandma and Grandpa's way, just to review, is where you add your 1s, you add your 10s, you add your 100s, and if there's extras, you note them at the top of the column. Partial sums, I still add all of them up, but I regroup them down here and then do my adding together. Okay, so there's 2 different ways for you to work on this. So 9 plus 2 is 11. So I'm just going to write 11. And again, it still matters. My 1s, my 10s, and my 100s columns still matter. Okay, now I'm going to do 20 plus 30. 20 plus 30 is 50. And then I'm going to do 200 plus 100. 200 plus 100 is 300. Okay, now I add these together. 1, 0, 0, 1. 1, 5 is 6, and 3. So it's 361. Now we are going to move on to the next one. Now this one, I have to regroup again. Again, I'm modeling the partial sums strategy. If you would prefer to use Grandma and Grandpa's way, I know we have some big fans of that in this class. Absolutely go for it. It's an awesome strategy. Partial sums is just really good when you're learning Grandma and Grandpa's way. If it's confusing you, try partial sums. Okay, so again, I have my 1s, I have my 10s, I have my 100s. I'm going to add my 1s. 5 and 6 is 11. I'm going to add my 10s. 60, because this is 165 and this is 516. 60 plus 10 is 70. And 100 plus 500 is 600. All right. Now, because I'm using partial sums, I regroup down here instead of up there. That's completely fine. I'm going to add them together. 1 plus 0 is 1. 1 plus 7 is 8. And 6 plus nothing is 6. So I have 6 hundreds, 8 10s, and 1 1. All right, on to number 3. So it says 270 plus 665. So again, I want to note where my 1s are, where my 10s are, and where my hundreds are, this would be a perfect one to use Grandma and Grandpa's way for if you're practicing that. But because I noted that a few people need some more practice understanding what these numbers mean, then we're going to practice partial sums because that's a good way to show it. Okay, so I start with my ones, and I add 0 and 6 for my ones. That's just 6. Then I'm going to add my tens. I have 70 and 50. Okay, so 70 plus 50, think 7 plus 5, which is 12. And since it's 70 plus 60, it's just going to be 12 with a 0 on it. 120. Now make sure your 100 is in the hundreds column. Make sure your 10 is in the tens column, and your 0 is holding that place in the ones column. Okay? Because if I just put a 12, and I put the 2 here, that's going to confuse me, and I'm not going to get the proper result. Okay, now 200 plus 600 is 800. Again, you just add 2 and 6 and think in hundreds. Now I'm going to add these two together. I've got 6 and 0 is 6. I've got 2 and 0 is 2, and 1 and 8 is 9. So I have 9 hundreds, 2 tens, and 6 ones. 926. Okay, now we get to go on to the next one. So, again, ones, tens, and hundreds. If you're using a different strategy, that's cool, guys. Just make sure you're getting the same result. You should have the same number of hundreds, the same number of tens, and the same number of ones, because no matter how you do math, and there's lots of ways to do math, your result is the same because those numbers don't change. Okay, now, I'm going to start because I'm doing partial sums. 4 plus 6 is 10. 40 plus 40 is 80. And 600 plus 200 is 800. And I'm making sure that all my numbers line up. All my numbers, my ones, my tens, and my hundreds, they're all lined up. Now I'm going to add them. 0 plus 0 plus 0. 1 plus 8 is 9. 10, so those are my tens. 10 plus 80 is 90. Oh, look, that's 90. And 8 plus 0 is nothing, so 800. So I have 8 hundreds, 9 tens, and 0 ones, 890. Okay, so we're going to move on. I'm going to zoom out so that you can see my arrays. We are going to move on to our arrays now. So it says, I know I've heard from a few people how much you guys are loving the arrays, and I hope that if you're not loving the arrays, you can learn to love them because they're going to make multiplication way easier for you to understand. Okay, and if you're like me, maybe math isn't something that comes at the snap of a finger. You need to work a little harder for it, and that just means that you're growing your brain, and that's okay. You're growing those neural pathways. So it says, now let's make arrays for these multiplication facts. Bonus, write the fact families that go with your array. I hope you're doing that because that's super awesome. Okay, and if you're not sure how to do that, follow along because I'm gonna show you. Okay, 2 times 5, I'm gonna just do x's for my array today. So I have 2 groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I have 2 groups of 5. Let's write that fact family. If you tuned in for my arrays and fact family bonus video, maybe you already know my spiel on this, but that's okay. So my multiplication is going to go up top. 2 times 5 is 10. And remember, commutative property of multiplication. If 2 times 5 is 10, I'm just going to zoom in because my writing's pretty small here. If 2 times 5 is 10, then 5 times 2 is also 10. Now I'm going to do my division facts. I'm going to do, again, we start, our dividend is the biggest number. It goes first. 10 divided by 2 is 5. And I know this because in a multiplication fact family, all the numbers in the house, all the equations in the house use the same 3 numbers. Okay, and then I'm going to do my second division. 10 divided by 5 is 2. Now, we need to do the basement. We need to do the foundation of our house. The foundation of every multiplication fact family is repeated addition. Okay, I know it doesn't ask for that, but I think it's important to practice. If you're tuning into this video, you can do it. So, you're just going to do repeated addition, so 5 plus 5, or 2 plus 2 plus 2 plus 2 plus 2. 2 plus 2 plus 2 plus 2 plus 2. And both of those are 10. Right? Okay, on to 3 times 4. Now we are working on the 2s and the 3s this week and next week. Next week I'm hoping to introduce you to a little bit of 4 times table, but we're just working through slowly to give you time to absorb it into your mind. Okay, 3 times 4. So I have 3 groups of 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There's my array. I've got lots of room to make my fact family now. So the top of my house, I'm going to put my multiplication facts. 3 times 4 is 12. And again, commutative property, 4 times 3 is also 12. Now my division sentences, we start with our dividend, our biggest number. 12 divided by 4 is 3. And 12 divided by 3 is 4. Now the foundation of every fact family. The foundation of every fact family is repeated addition. So now I get to do my repeated addition. So 4 plus 4 plus 4 equals 12. And 3 plus 3 plus 3 plus 3 is also 12. Okay, now I'm going to move on to 3 times 7. Now I might run out of room with my repeated addition when I'm doing 7 groups of 3. But let's not fret about that. Let's just draw our array to start. So it's 3 groups of, because that X just means groups of, 7. So I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I'm trying to follow my rules of arrays, which means I'm keeping them in as straight lines as possible. 1, 2, 3, 4, 5, 6, 7. Okay, so I have 3 groups of 7. Let's draw that fact family. Let's work on that fact family. So 3 times 7 is 21. I'm sure you've heard me say that's my favorite 3 times table fact. And again, commutative property, 7 times 3 is also 21. Now my division, I'm going to start with my biggest number, 21 divided by 7 is 3. 21 divided by 3 is 7. All the numbers in this fact family house, they are the same. So 3, 7, and 21 just rearranged to make sense. Now the foundation, the basement of my multiplication facts is always repeated addition. So 3 times 7, I've got 7 plus 7 plus 7. 7 plus 7 plus 7 equals 21. Now I'm going to do my other run. Whew, get ready. 3 plus 3 plus 3 plus 3 plus 3 plus 3. Do I have enough? 1, 2, 3, 4, 5, 6, and 1 more plus 3 is 21. And this is why we do multiplication, we write repeated addition with this X with groups of. Otherwise, this would get really old really fast. 3 plus 3 plus 3 plus 3 plus 3. It's just a different way to represent those numbers, guys. Now, 3 times 5. 3 times 5. So I have a couple choices here. 3 times 5, I've got 1, 2. So it's 3 groups of 5. I don't know why I said I have a couple choices. I guess I could write 5 groups of 3 too. I don't know where I'm going with that. Okay, 1. So I've got 3 groups of 5. Focus, Mrs. Oaks. 3 groups of 5. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my arrays are getting messy. I've been filming a lot of videos. Mrs. Oaks, they've got to be neat. Otherwise, they're just a collection of dots. Okay, 3 times 5. Let's write my multiplication up top. 3 times 5, because multiplication goes at the top of this family's house. 3 times 5 is 15. Now, commutative property, I can switch them. 5 times 3 is also 15. Now on to the next one. 15 divide by 3 equals 5. 15 divide by 5 equals 3. Foundation of any fact family for multiplication and division is repeated addition. So I have 5 plus 5 plus 5. And then I've got 3 plus 3 plus 3 plus 3 plus 3. 3, 2, 3, 4, 5 groups of 3 is 15. And I should always put, for an equation to be balanced, it needs to have an equal sign, right? Now 3 times 6, so I've got 3 groups of 6. 1, 2, 3, 4, 5, 6. Okay. Okay, so I was drawing my array. So I have 1 group of 6. Now 1, 2, 3, 4, 5, 6. That's 2 groups of 6. 1, 2, 3, 4, 5, 6. That's 3 groups of 6. Now, build my house. I have multiplication, so it's 3 groups of 6. 3 times 6. Now remember, if you're not familiar with 3 times 6, you could always count by threes. 3, 6, 9, 12, 15, 18. 3 times 6 is 18. Now I have all 3 numbers in my fact family. So do you. If you want to pause the video and make your fact family, then come back and check, let's practice that. So pause it, make your fact family, and come back and check it. All right, so I hope you did that. 6 times 3 is 18. Commutative property. 18 divided by 3 is 6. 18 divided by 6 is 3. Now, the bottom of my fact family house is always repeated addition. So I go 6 plus 6 plus 6 equals 18. And then I have 1, 2, 3, 4, 5, 6 groups of 3 is also 18. And there you go. I've got these 2 here. That's my fact family for 3 times 6. Now 3 times 3, this is a nice square. Watch. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I have 3 groups of 3. Now I'm going to do, and look, it's a square. It's a pretty sad square on my part, but that's okay. Now, because it's 3 and 3 both ways, it's a square number, it's square. So now I am going to write out my fact family. I forgot what I was saying for a minute. All right, 3 times 3 is 9. Now for this one, I can't write another fact. You could write 3 times 3 out again, but it doesn't matter which way you write the 3's, they're going to look the same. So I could take this 3 and put it here, and put this 3 over here, and 3 times 3 is 9. You don't have to do that. And then 9 divided by 3 is 3. Again, I don't have to write that twice because it's the same fact. So this family doesn't have as many variations. Now, 3 plus 3 plus 3 equals 9. That's the only repeated addition I can do for this. Okay. Now, I'm going to move on to the next here. When we multiply numbers, we can use skip counting to help us remember our facts. Let's review skip counting by 5s. See if you can find any patterns in the 100 chart once you're done. So all you're going to do, and I really would love it if you could pause the video and try this on your own. If you really don't want to do that, you could work along with me to begin with and then pause the video and try it on your own. But I'm going to go quick because we've done this before. This is a review. So you're just going to start at 5s and shade in every 5th number. Okay, so look, let's do it real quick. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100! Whew. Now, you guys all know how to count by fives. I've heard everyone do it. I know you've got this. So now we're going to write the skip counting sequence. Now, it's going to be a little bit hard to see, but you have all the numbers up here. So I'll do my best to show you, but you guys have got this, okay? So we'll talk, I'll count as we go. You can go along with me, or you can do this part on your own. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Whew, you did it. Now it says, did you know that you can use skip counting to solve a multiplication equation? This is the strategy I usually teach for 5 times 5 because it's such an easy strategy to remember because you learn to skip count by fives very early on in your school career. Okay? So, example, 3 times 5, think, and you can't really see my hands, but 5, 10, 15. I skip counted by 5 3 times, and I know it's 15. Remember, even if the equation is flipped, you can still skip count by fives. For example, 5 times 4, think 5, 10, 15, 20. Write the skip counting sequence that you could use to solve 5 times 5. 5, 10, 15, 20, 25. Now, 4 times 5. 5, 10, 15, 20. Now, I'm going to switch to my camera view and I'm going to give you a couple ideas of ways that you can practice this and use this to get better at multiplication, okay? Now I'm going to show you how to use skip counting to do your 5 times tables. So I'm going to give you a couple and then I want you to work on your own and try a few, okay? So if I do 5 times 7, all I have to do is skip count by 5 7 times. So let's try it. 5, 10, 15, 20, 25, 30, 35. And in case you're wondering, that is correct. Now, I'm going to give you another one. 5 times 8. Now, you could skip count, or you just know the count, think the pattern in your head. 8 is one more than 7. You could think 40 if you wanted to check that. 5, 10, 15, 20, 25, 30, 35, 40. I counted 8 groups of 5. Sorry, it's been a lot of video shot today. 8 groups of 5, and that's 40. All right, and I'm going to do one more, and then I'm going to challenge you to try and do your 5 times table using this strategy and send me a picture of what you do. Again, this is in addition to your work. You don't have to do it, but I'd love to see how you're getting along with this. I just don't want to overload you with your work time. So if you have time today and you're feeling it, practice, write out all your 5 times tables and practice your skip counting and let me know how you feel about that. So I'm going to give you 5 times 6. Now I want you to pause the video, skip count by 5s 6 times, and then come back, press play to figure out what it is. Okay, so 5 times 6, hopefully you're pausing the video, you're going to skip count by 5s 6 times. Okay, and what did you get? Did you pause the video? Do it. Okay, hopefully you did it. 5 times 6 is 30. Now, for some extra math, you can practice skip counting by 5s. You could do our trick with the cards where you flip over the cards and say you get a 6, you skip count by 5 6 times, and you say 5 times 6 is 30. Say you get a 10, you skip count by 5 10 times, 5 times 10 is 50. Practice skip counting by 5s, practice relating it to your multiplication. I promise this is probably going to be your favorite multiplication family, the 5s. Every kid loves the 5s. So take some time, have fun, play with them. I still have grade 5s that when they see that something, we might have this big question like 3,257, and if it's got times 5, they'll go, yes, I can do that, I know that, I love 5s, because they have practiced their 5s, so 3,257 times 5, the grade 5s know it, because they know, well, I'll show you when you get to grade 5. You don't just know your facts, but they can use the facts they know to multiply this big number. My grade 4s and my grade 5s. And when they see 5, they get really excited. 5 is a favorite. It's a student favorite. So go practice your 5s. Take about 10 minutes. Just practice your 5s. You can send me a picture of your 5 times table work, or send me a message and say, Mrs. Oakes, I love 5 times tables. Or Mrs. Oakes, I think I'm getting it. I need to practice some more. Okay? 5 times table. It's very fun. Thanks. And that's it. You did it. You did it. You're all done your math for today. Good job. If you could use some more math practice, you could practice skip counting. You could practice your math facts. You could play a math game. You could go on SumDog or Reflex or Prodigy or any one of those things. Or if you think that that whopper of a math video was enough for you, then take a breath and just enjoy the fact that you did it. I would like to ask a question of everybody that is watching this far in the video. If you get a chance and you have a handy device, once you're done your work, as you're working on it, if something comes up and it's really hard, just make a note of it right on your sheet. So you could put a note right there and just put an arrow to it and say, that was hard. Or if something's super easy and you want to tell me and celebrate that something is easy for you, then you can put a note and say, that was super easy. I love these. Maybe you love arrays. I heard from a couple people how much they're loving the arrays. Okay, so just go through, and if you'd like to, if you can, if you have a device, I know we're all working differently, but just take a picture and send it to me on Class Dojo or Teams when you're done your work. If you'd like to share with me how things are going, because I'm very interested to see if there's something that's hard for a lot of people, then I'll make sure I cover it in other videos. If there's something that you guys are loving, I want to put more of that in our videos, right? So send me a picture of whatever you're doing, whatever you've done. You could even just put smiley faces if you like it and frowny faces if you don't like it. Or, yay, I love these, or boo, these are hard. Again, this is going to help me as I design your work packets for next week or the week after, right? So I'm doing my best to respond to what you guys need, but that's harder when you're not in front of me, okay? Usually I plan my math based on what I see in math class, and it's hard to know if I don't get that feedback. So if you could just put smiley faces, grumpy faces, and make comments and send me a picture of your math, okay, how you're doing with it, I would love to see it, because then that will decide how I move forward. Hopefully next week I'm hoping to do a flip grid with you guys. If you can, I'll be sending the code out for that just to see how you're doing with arrays. But we're going to practice some more first, so don't worry. Don't panic. Okay, so for now, you can send me a picture of your math and let me know how it's going at home. Or just send me a message and say, loving arrays, still don't like addition. Whatever it is, or loving arrays, loving addition. Whatever you're working on, however you're feeling about math, it matters to me and I want to hear it. Okay? Have a fantastic day. Check in on Teams on the Math channel if you'd like. I also posted to Dojo a mashup math today. So check in for the mashup math, and if you can solve it, you can take a screenshot of the mashup math and click edit, and you can write right on it and then just send me a picture of it. Or you can just do it on paper by looking at it. Whatever works for you. If you have a sibling at home, you could challenge them to the mashup math, see if they can get it, because that's algebra and it's super important. It's a super important skill that we usually practice all the time. So if you need more math, check out the math channel on Teams or my Class Dojo class story. And thank you for listening to this long spiel. I can see that I've been talking for 3 minutes, and that's too long. All right, have a wonderful day, everybody. I will see you back on Friday for more math.